Hi there, I'm Hao, and this is just another video of me solving random leet code problem. So let's begin. So this is a an alternative problem of subset. So in this case, the set we have the input array may contain duplicates, right? And we want to return the all possible subset that has to be unique. Okay. So in our normal subset, right? If our num have unique elements, which means that our resulting array, our result, won't have any duplicates, right? But in this case, because the nums input array can contain like duplicate elements, so we will have duplicate result, right? Duplicate subset. So an easy strategy is that we can have our before pushing so before pushing the subset into our array, um, we can we can check if we already seen a subset, right? We can have a set to keep track of the subset that we have seen, so we can avoid duplicate. If we have like a set like this, 1, 2, 2, like the example, right? We can start with an empty array. We can either select, right? So the first number is 1, so we can either select 1 or not selecting anything, right? So we not select anything on the left, right? And we can select 1 on the right, right? The next number is 2. We can choose to not select or select, right? 2. Same here. We can choose to not select or select. Right. Same here for the last number is 2, right? So we can choose to not select and we can choose to select. We can choose to not select and we can choose to select. Same here, not select, right? Select, not select, and select, right? So this will be our subset, right? As you can see here, we have a lot of duplicates, right? 1, 2, and 2, 2, and 2, right? So if we have a set, right, where we keep track of the visited subset, then we can avoid duplicates, right? Okay, so that is only one of the problem. Why? Because coincidentally, in our example, the array is sorted, right? What if the array is not sorted? Let's say if we already have 2, 1, 2, then we're gonna have something like this, right? Two. So this is not select, right? Just 1, not select, 1, not select, select 1. Okay, and the last one is 2. So not select, select 2, not select, select 2. So not select and then select 2, so 2 and 2. Not select and then select 2, 2, 1, 2. Okay, so as you can see here, the problem is that even though we are keeping track of the visited, right, subset, but the subset might be different, maybe the same but also different. What does it mean? It means that if you look at 1, 2, and 2, 1, right, they are the same, but they are in the different order, because for subset order doesn't matter, right? For permutation, the order matters, but for subset, the order doesn't matter, right? 1, 2 is the same as 2, 1, right? So how could we handle this case, right? Because if the array is not sorted, then we not only that we not only we have duplicate subset, but we also have duplicate subset that in like different order, right? So we can choose to sort uh the, the subset every time we add it to the set, right? But that is very inefficient because we need to sort it every time we want to compare or every time we want to add something into the set. So instead, we can also set the input, sorry, sort the input every time, sort the input before we even do the startup backtracking, right? So if the input is sorted, right? If the input is sorted, we know that when we have duplicates, we know that they will be in the same order, right? 1, 2, 1, 2. We're not gonna have run into the case of like 1, 2, and 2, 1 like this when the input is not sorted, right? So what is our time complexity? It's over 2 to the n, right? Because we have two paths, and then the depth of the recursion would be n, which is the length of the nums here, right? And we need to multiply by n because every time we push the array into our resulting array, right? Every time we put a subset into our resulting array, we need to make a copy, right? And that is O of n. Because we are using backtracking, so we want to be able to reuse the component, right? Just to reuse the array. We had to be able to mutate the array, right? So for example, right, we can select one, right? But when we return back up, we can pop it off, right? And then try with a different option, right? Okay, so that is our general strategy again. To avoid the duplicate subset, right? We have a hash set to keep track of the visited subset, right? And that is the first thing. The second thing, and to ensure that the subset, the duplicate subset, right, are always in the correct order, we have to sort the input array before we do the backtracking, right? Because for subset, order doesn't matter. Okay, so let code this up. All right, so let's see. We will have our result array, of course. We will return it at the end. All right, and we will need to sort the input. Okay, and we have to do the backtrack. We start with an empty array, and then um, 0. Right? 0 will be the index, the current number we are looking at, right? So what is our base case? So if index is equal to the length of length, which means we have file and input, right? So we want to push it into our resulting array, right? But we only want to do that if we haven't seen it, right? So we need our set here. Let's call it since, right? Equal to new set. So we cannot add the array directly into our set, right? Because it is a reference type. We need to turn it into a string first. So we can call it, and we need to also make a copy, right, of our array because we want to mutate it later, right? So copy string equal to copy dot string, and we can do if c has not has it doesn't have the copy string, which is the array here, the key here, right? We want to add it, right? Scene dot add copy string, and then we want to push it into our array. Copy. And then we want to return. Right. So this is our base case. So again, our base case is when we reach the end, right, of the input. Right, so as you can see here, we are basically over here, looking at each number, right, the next number at each iteration level until we have until we reach like the length of the input, right? Okay, so that is our base case. Before we push, we need to make a copy because we want to mutate the array later, and then we need to turn it into a string, right? Because we cannot store an array in our set. Yeah, so if it's not in the set, we just add it into the set and push it into our resulting array. Okay, so now is the base case. So we can add the array, add the new elements, right? Num index, and we can do the backtracking again, right? At index plus one, and then the array, right? And then we can pop it off, backtrack index plus one, then the array, right? So we have remember we have two paths. So the first path is when we select the element, right? And the second part is when we're not selecting the element. That's reiterating that. Okay. And then it work. And thank you for watching.